Hello my lovely students, you are welcome to a new lesson. Today, I shall be teaching you theory of logarithms. From definition, logarithm means power or index or exponent. For example, the logarithm to the base 2 of 64 is equal to 6. Let's learn more about the theory of logarithms. Before we continue with the theory of logarithms, let's have a revision on indices. Indices is the plural of index. Index means power or exponent. Let's see the laws of indices. The first law is the multiplication or product law, which says multiplying indices of the same base, we add the powers. In other words, p raised to the power m times p raised to the power n is equal to p raised to the power m plus n. The second law is the division or the quotient law, which says dividing indices of the same base, we subtract the powers. In other words, p raised to the power m divided by p raised to the power n is equal to p raised to the power m minus n. The third law is the zero index, which says a number raised to the power 0 is equal to 1. In other words, p raised to the power 0 is equal to 1. The fourth law is the negative index, which says a negative power will produce a reciprocal. In other words, p raised to the power minus n is equal to 1 over p raised to the power n. The fifth law is the power index, which says when you have indices raised to power another power, we multiply the powers. In other words, p raised to the power m in bracket raised to the power n is equal to p raised to the power m times n, which is p raised to the power mn. The sixth and seventh laws of indices involves fractional index. Here, when we have a fractional index, it will produce a root. In law number 6, p raised to the power 1 over n is equal to the nth root of p. For law number 7, p raised to the power m over n is equal to the nth root of p raised to the power m. Here we can choose to do the power first, that is p raised to the power m in bracket first, before we do the nth root of the result later. Or we can choose to do the nth root first, that is the nth root of p in bracket first, then we'll do the power of m later. Please take note that in all these 7 laws of indices, the base of the indices p must not be equal to 0 in all cases. I hope these 7 laws of indices, they are all clear to you. Moving on, let's see the laws of logarithms. Law number 1. The logarithm of m times n is equal to the logarithm of m plus the logarithm of n. Law number 2. The logarithm of m divided by n is equal to the logarithm of m minus the logarithm of n. Law number 3. The logarithm of m raised to the power n is equal to n multiplying the logarithm of m. Law number 4. The logarithm to the base x of m is equal to the logarithm of m divided by the logarithm of x. This fourth law is called the change of base of a logarithm. Law number 5. The logarithm to the base 1 over x of m is equal to minus the logarithm to the base x of m, which is equal to minus the logarithm of m divided by the logarithm of x. Law number 6. The logarithm to the base m of the same number m is equal to 1. Law number 7. the logarithm of 1 is equal to 0. Law number 8. The logarithm to the base x raised to power n of m is equal to the logarithm of m divided by the logarithm of x raised to power n, which is equal to the logarithm of m divided by n multiplying the logarithm of x. Please take note of all these laws of logarithms. Moving on, let's learn about logarithmic equations. Logarithmic equations are equations with logarithms. In general, if n is equal to an index of base a raised to power x, which is an exponential equation, then we can transform this exponential equation into a logarithmic equation such that the logarithm to the base a of n is equal to x. Please take note of this transformation between an exponential equation and a logarithmic equation. Next, let's see our first example on laws of logarithms. Example 1. Evaluate the following. Question A. Logarithm to the base 3 of 27. Question B. Logarithm to the base 4 of 8. Question C. Logarithm to the base 5 of 0.04. Let's see the solution to question 1a. Logarithm to the base 3 of 27 is equal to logarithm to the base 3 of 3 raised to power 3, which is equal to 3 multiplying the logarithm to the base 3 of 3. Don't forget, the logarithm to the base 3 of 3 is equal to 1. This gives 3 times 1. The answer to question 1a is 3. Another way we can solve question 1a is to change the base of the logarithm. In other words, logarithm to the base 3 of 27 is equal to logarithm of 27 divided by logarithm of 3. When we simplify this, we will get logarithm of 3 raised to power 3 divided by logarithm of 3, which is equal to 3 multiplying the logarithm of 3 divided by the logarithm of 3. When we divide both logarithm of 3 in the numerator and denominator, our answer to question 1a is equal to 3. Another way we can solve question 1a is to use our logarithm tables. In other words, the logarithm to the base 3 of 27 is equal to the logarithm of 27 divided by the logarithm of 3. The logarithm of 27 using logarithm tables is 1.4314 and the logarithm of 3 using logarithm tables is 0.4771. When we divide these values, the answer to question 1a is equal to 3 again. I hope the solutions to question 1a they are all clear to you. Now, using these ideas in question 1a, what will be the answer to the question in 1b, talking about the logarithm to base 4 of 8? Let's see if you are right. For the solution to question 1b, when we change the base of the logarithm, we are going to get the logarithm of 8 divided by the logarithm of 4. Simplifying this, that gives us the logarithm of 2 raised to power 3 divided by the logarithm of 2 raised to power 2. Next, when we write the powers as the coefficient of the logarithm, we are going to get 3 multiplying the logarithm of 2 divided by 2 multiplying the logarithm of 2. When we simplify this, what will be the answer to the question 1b? Let's see the correct answer. The answer to question 1b is 3 over 2, which is equal to 1.5. I hope you got that right. Here is another way we can solve question 1b. This method involves the use of logarithm tables, where the logarithm of 8 is 0.9031 and the logarithm of 4 is 0.6021. When you divide, we will get the answer once again, which is 1.5 or 1.5. Next, can you tell the answer to question 1c, talking about the logarithm to the base 5 of 0.04? Let's see if you can. Here is the solution to question 1c, where in changing the base of the logarithm to the base 5 of 0.04 is equal to the logarithm of 0.04 divided by the logarithm of 5. Changing 0.04 from decimal to a fraction, we have 4 divided by 100. Simplifying your fraction, we have the logarithm of 1 over 25 divided by the logarithm of 5. This will simplify into the logarithm of 5 raised to the power minus 2 divided by the logarithm of 5. When we apply the laws of logarithm and we simplify, the answer to question 1c is minus 2. I hope you got that right. Next, let's see our second example on laws of logarithms. Example 2. Evaluate the following. Question A. Logarithm of 7 plus 2 times the logarithm of 2 minus the logarithm of 280. Question B. Logarithm of 20 over 9 plus 2 times the logarithm of 6 over 5 minus the logarithm of 4 over 125. Question C. Logarithm to the base 5 of 3 over 5 plus 3 times the logarithm to the base 5 of 15 over 2 minus the logarithm to the base 5 of 81 over 8. Let's see the solution to question 2a. Here we have the logarithm of 7 plus 2 times the logarithm of 2 minus the logarithm of 280. The first thing we have to do is to simplify the middle term by moving the 2 multiplying the logarithm of 2 to become the power of the logarithm of 2. That will give us the logarithm of 4 as the middle term. Next, when we apply the laws of logarithm, what will this simplify into? Let's see if you are right. From the laws of logarithm, adding 2 logarithms means multiplying the 2 logarithm numbers, while subtracting a logarithm involves dividing by the logarithm number. In other words, logarithm of 7 plus logarithm of 14 minus logarithm of 280 becomes the logarithm of 7 times 4 divided by 280. I hope you got that right. Simplifying this result, we are going to get the logarithm of 1 over 10, which is equal to the logarithm of 10 raised to the power minus 1. This gives minus the logarithm of 10. Please take note that since the base of the logarithm is not written, the base number is actually 10. Hence, minus the logarithm to the base 10 of 10 is equal to minus 1. I hope the solution to question 2a is clear to you. Now, following this idea, can you tell the answer to question 2b, talking about the logarithm of 20 over 9 plus 2 times the logarithm of 6 over 5 minus the logarithm of 4 over 125? Let's see if you are right. Here is the solution to question 2b. Once again, the first thing we have to do is to simplify the middle term, which is 2 times the logarithm of 6 over 5. To do this, the 2 multiplying the logarithm becomes the power of 6 over 5. That gives us the logarithm of 36 over 25 as the middle term. Next, let's apply the laws of logarithms involving the addition of logarithms and the subtraction of logarithms. Question 2b leads to logarithm of 20 over 9 times 36 over 25 divided by 4 over 125. This will lead to 20 over 9 times 36 over 25 times 125 divided by 4. That is inverting the dividing fraction. and changing the division sign to multiplication sign. This will lead to the logarithm of 100, which when simplified, our answer is 2. I hope you got that right. Next, can you tell the answer to question 2C? Let's see if you can. Here is the solution to question 2C. Talking about the logarithm to the base 5 of 3 over 5 plus 3 multiplying the logarithm to the base 5 of 15 over 2 minus the logarithm to the base 5 of 81 over 8. Once again, let's simplify the middle term by moving the 3 multiplying logarithm to the base 5 of 15 over 2 to become a power of 3 of 15 over 2. That gives the logarithm to the base 5 of 3375 over 8 as the middle term. Next, let's apply the laws of logarithms here. When we apply the laws of logarithms, this is our result. Now let's see our final answer. Our final answer is logarithm to the base 5 of 25, which we simplify to 2. I hope you got that right again. Please take note of all the solutions to example 2. Next, let's see our third example for laws of logarithms. Example 3. Given that the logarithm to the base 10 of 2 is equal to 0.3010 and the logarithm to the base 10 of 3 is equal to 0.4771. Evaluate question A, logarithm to the base 10 of 9, question B, logarithm to the base 10 of 12, and question C, logarithm to the base 10 of 15. Let's see the solution to question 3A. Simplifying the logarithm to the base 10 of 9, we are going to get the logarithm to the base 10 of 3 raised to power 2, which will simplify into 2 multiplying the logarithm to the base 10 of 3. When we substitute 0.4771 for the logarithm to the base 10 of 3, what will be our answer to question 3A? Let's see if you are right. Substituting 0.4771 for the logarithm to the base 10 of 3, our answer to question 3A is 0.9542. I hope the solution to question 3A is clear to you. Next, let's see the solution to question 3B. For question 3B, the logarithm to the base 10 of 12 can be simplified into the logarithm to the base 10 of 4 times 3, which gives us the logarithm to the base 10 of 2 raised to power 2 times 3. Applying your laws of logarithms, this will simplify into the logarithm to the base 10 of 2 raised to power 2 plus the logarithm to the base 10 of 3. In other words, the logarithm of a product is equal to the addition of the separate logarithms. When we simplify this, we have 2 multiplying the logarithm to the base 10 of 2 plus the logarithm to the base 10 of 3. Now, when we substitute 0.3010 for the logarithm to the base 10 of 2 and substituting 0.4771 for the logarithm to the base 10 of 3, what will be our answer to question 3B? Let's see if you are right. From substitution, our answer to question 3B is 1.0791. I hope you got that right. Now, from the solutions to question 3A and 3B, can you tell the answer to question 3C? Talking about the logarithm to the base 10 of 15. Let's see if you can. For the solution to question 3C, the logarithm to the base 10 of 15 can be simplified into the logarithm to the base 10 of 30 divided by 2. That gives us the logarithm to the base 10 of 3 times 10 divided by 2. Applying the laws of logarithm, that gives us the logarithm to the base 10 of 3 plus the logarithm to the base 10 of 10 minus the logarithm to the base 10 of 2. Don't forget, the logarithm to the base 10 of 10 is 1. When we substitute 0.4771 for the logarithm to the base 10 of 3 and 0.3010 for the logarithm to the base 10 of 2, our answer to question 3C is 1.1761. I hope you got that right. Next, let's see our fourth example involving logarithmic equations. Example 4. Solve x raised to the power 0.8265 is equal to 45. Let's see the solution to example 4. X raised to the power 0.8265 is equal to 45 is an exponential equation. Next, let's take the logarithm of both sides to base 10. This will give us the logarithm to base 10 of x raised to the power 0.8265 is equal to the logarithm to base 10 of 45. Now we have a logarithmic equation. Simplifying this by applying the laws of logarithms, we are going to get 0.8265 multiplying the logarithm to base 10 of x is equal to the logarithm to base 10 of 45. Now, using our logarithm tables, the logarithm to base 10 of 45 is 1.6532. Next, when we divide both sides of this equation by 0.8265, we are going to get the logarithm to the base 10 of x is equal to 2. Transforming this logarithmic equation into an exponential equation again, we will have the logarithm to the base 10 of x is equal to 2, becoming x is equal to indices of base 10 raised to power 2. When we simplify this, our answer is x is equal to 100. I hope the solution to question 4 is clear to you. Here is another method of solving example 4. The question is x raised to the power 0.8265 is equal to 45, which is an exponential equation. This exponential equation can be transformed into a logarithmic equation, which is 0.8265 is equal to the logarithm to the base x of 45. By applying the law of logarithms, which involves the change of base of a logarithm, this will simplify into the logarithm to the base 10 of 45 divided by the logarithm to the base 10 of x. When we use our logarithm tables, the logarithm to the base 10 of 45 is equal to 1.6532. When we simplify this equation, we are going to get the logarithm to the base 10 of x is equal to 2. Solving this further, our answer to question 4 remains x is equal to 100. Please take note of this second method of solving example 4. Next, let's see our fifth example involving logarithmic equations. Example 5. Find the value of k, given that the logarithm of k minus the logarithm of k minus 2 in bracket is equal to the logarithm of 5. Let's see the solution to example 5. Applying the laws of logarithm, the logarithm of k minus the logarithm of k minus 2 in bracket is equal to the logarithm of 5. We simplify into the logarithm of k divided by k minus 2 is equal to the logarithm of 5. In other words, subtracting two logarithm values will produce the logarithm of the division of the two values. When we simplify this equation by striking off the logarithm on both sides of the equation, we will have k divided by k minus 2 is equal to 5. Cross multiplying, we have k is equal to 5 into k minus 2. When you solve this simple equation, what will be the value of k? Let's see if you are right. For k is equal to 5 into k minus 2, removing the bracket, we have k is equal to 5k minus 10. Collecting your like terms for k, we have 10 is equal to 4k. Dividing both sides by 4, the value of k is equal to 2 whole number 1 over 2. I hope you got that right. Next, let's see our last example for logarithmic equations. Example 6. Find the value of x, given that the logarithm to base 10 of x plus the logarithm to base 10 of x plus 3 is equal to 1. Let's see the solution to example 6. Applying the law of logarithms to our logarithmic equation, logarithm to base 10 of x plus the logarithm to base 10 of x plus 3 is equal to 1 becomes the logarithm to base 10 of x multiplying x plus 3 is equal to 1. Next, converting this logarithmic equation to an exponential equation, we are going to have x into x plus 3 is equal to 10 raised to power 1. In other words, the logarithm to base 10 on the left hand side of the equation becomes indices to base 10 on the right hand side of the equation. When we simplify this exponential equation, we are going to have x into x plus 3 is equal to 10. Removing the brackets, we have x squared plus 3x is equal to 10. When we arrange this equation properly, we are going to have a quadratic equation, which is x squared plus 3x minus 10 is equal to 0. When you solve this quadratic equation, what will be our value of x? Let's see if you are right. Factorizing the quadratic equation, we are going to have two factors, which are x plus 5 into x minus 2 is equal to 0. Solving these two factors separately as equal to 0, we will have x plus 5 is equal to 0 or x minus 2 is equal to 0. When we make x the subject of both equations, we have our final answers, which are x is equal to minus 5 or x is equal to 2. I hope you got that right. Finally, I hope the solutions to all the solved examples involving the theory of logarithms, they are all clear to you. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic theory of logarithms, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.